Film will give you, as a student, an overview of the processes within a hot rolling mill. The film is made in collaboration with SSAB in Borlänge. Here, the steel material is processed plastically at very high temperatures. Rotating rolls reduce the thickness of the material and produce long strips that can be used for manufacturing products such as steel plates. We will be going through the various stages of the hot rolling process. Each stage requires knowledge and experience to ensure a high-quality product. The material is heated in the reheating furnace, rolled in the roughing mill, coil boxed, roll in a finishing mill, cooled and coiled. Before the slab can be processed, it must be heated. The slab is continuously cast and has the dimensions required for the final product of a correct weight, width, and thickness. These furnaces heat the material to about 1200 degrees centigrade. 2 walking beam furnaces feed the material through the oven. The heating is especially important as it affects the properties of the material. If the material is not sufficiently heated, incorrect material properties will arise. This is due to carbides and nitrates failing to dissolve. During the heating process and the transport to the roughing mill, the hot material reacts to the oxygen in the air, and a mill scale consisting of oxide is formed on the surface. If the oxide layer remains on the material during rolling, the layer risks being rolled into the steel material, adversely affecting the surface quality of the final product. The material must undergo a mill scale cleansing before rolling. In order to cleanse the surface, water is sprayed at high pressure, 160 bar. After the material has undergone a surface cleansing, it's sent to the roughing mill. Here, the material is rolled from its original thickness of 22 centimeters down to about 3 centimeters. This is a very significant reduction. At this roughing mill, a powerful 4-high rolling mill is used. That is, 2 backup rolls and 2 smaller working rolls. The backup rolls are often cast steel rolls. The working rolls must have very smooth surfaces and tolerate high temperatures and wear, as they are in direct contact with the material. This particular material is rolled with 5 passes, where 1 pass means that the material passes through the rolls once. The material is surface cleansed several times during the roughing mill process to remove any new traces of mill scale. In order to control the width of the material, vertical rolls are used. The material is now called transfer bars. After the roughing mill, the transfer bar is rolled up in a coil box. The coil box's primary purpose is to save space, but when inside the coil box, a temperature equalization also occurs. The temperature difference between the ends of the material is minimized as the transfer bar is coiled together. When the transfer bar is removed from the coil box, it has a temperature of about 1050 degrees centigrade. The ends of the transfer bar are cut off and the bar undergoes further mill scale removal. After this, it's time for the next stage, the finishing mill. This mill consists of 6 stands in the shape of 4 high rolling mills. Here, the transfer bars, now called strips, are rolled into a thickness of between 16 and 1.8 millimeters. Between the rolls we see an uplooper, which measures and controls, amongst other things, the line speed, and the strip tension. The swinging motion that can be observed is when the uplooper is adjusting itself. In order to control the profile and the flatness of the strips, the working rolls are horizontally adjustable. The first stands control the profile, and in the later stands the flatness is controlled. It's very important to have a correct strip profile and flatness before any post-processing starts. The cooling rate is adapted to each strip to produce the appropriate microstructure and material properties of the end product. When the strip has passed through the cooling section, it's coiled in. The temperature during coiling varies between 150 and 750 degrees centigrade, depending on the properties assigned to the material. After coiling and the subsequent cooling, the strip can be sold directly to the customer or undergo additional processing stages, for instance, cold rolling.